day was April 12th, 1961. Mankind had conjured up one of the biggest challenges of all time, conquering space, which probably they have never thought possible before. On that day, it ushered in countless research, thousands of sleepless nights, and numerous attempts to achieve this bigger dream. Yuri Alexeyevich Gagarin is the man who brought out this ray of hope to the existing humanity that individuals' will can make any unimaginable imaginable. He was a young Soviet pilot and cosmonaut to leave the imprint of becoming the first human in space. He traveled around Earth aboard the Vostok 1 space capsule, speeding at 27400 kilometers per hour, and the journey lasted 108 minutes. This day marked one of the greatest days in history. Praises were coming from far and wide. Thousands of people witnessed the event, and everyone had only one talking point: mankind had stepped into space. But do we know the backstory of this great mission? It wasn't only Gagarin's determination, the spacecraft, and the programming crew who helped him achieve this success. There's one thing that remained quiet, but played the most important role in the mission: the spacesuit. If you have at least a little knowledge about space, you know why a spacesuit is super important for an astronaut. However, this story isn't just about importance, tech, or revolution. It's about the whole journey of spacesuits. Harking back to history, Russia's name will pop up first, because it was the country who made the first spacesuit way back in 1931. That time, people used to call Russia Soviet Union. Spacesuits help astronauts to head for unruly expeditions into space. To know the history of spacesuits, let's take a trip down memory lane over the past 60 years. Actually, the spacesuits we use now were built using the technology from the Apollo era back in the 1960s. This means they're made with older technology compared to what we usually encounter today. In journeys through space, astronauts have depended on some amazing tools, and among them, the spacesuit stands out as one of the most extraordinary. These suits act as individual spacecraft for astronauts. Regardless of the nature of the mission, spacesuits are crucial for astronauts during missions because they keep astronauts safe and enable them to perform important tasks. Modern suits like the Extravehicular Mobility Unit act as mini life support systems. They allow astronauts to move and work, whether they are fixing things or building on the International Space Station. These suits are vital for protecting astronauts in space, ensuring they can work effectively and safely in this challenging environment. The story of spacesuits is all about how they have changed over time to meet the needs of different space missions, from the early Mercury missions to the Apollo missions and beyond. Each mission has taught scientists something new and helped them improve spacesuit designs for future space adventures. Between 1958 and 1963, Project Mercury was the first US effort to send humans into space. The mission was designed to orbit a manned spacecraft around Earth, assess human capabilities in space, and ensure the safe return of both astronaut and spacecraft. This ambitious project required innovative technologies, including the first American spacesuit. And to make it a sure success, the US introduced the Mercury suit for the very first time. But forming the suit to make it ready for any possible scenario wasn't a child's play. To safeguard astronauts from sudden pressure changes, NASA repurposed high-altitude jet aircraft pressure suits from the US Navy, originally designed for pilots facing cabin pressure loss. These suits, known as the Mercury suits, were crucial in protecting astronauts in space. They were specially adjusted to ensure both safety and comfort, allowing astronauts the flexibility they needed to move and work effectively inside their spacecraft. Basically, the Mercury suit was made with two layers. The inner layer was neoprene-coated nylon, which made it flexible and airtight. It helped astronauts to protect themselves from losing pressure. The outer layer was aluminized nylon, which reflected solar radiation and helped keep the suit's temperature steady. This reflective outer layer was very important for dealing with the extreme temperature changes in space. Although Mercury suits are mainly designed for emergency situations, it was not meant for spacewalks. The astronauts would want to use it to protect themselves from losing cabin pressure and keep them safe inside the spacecraft. These suits were made for use inside the cabin, which will allow astronauts to do their mission tasks comfortably while staying protected. Even though it wasn't as flexible as later spacesuits, the Mercury suit still let astronauts move around freely to handle spacecraft controls and perform their tasks. During the 6 crewed Mercury flights, astronauts donned the Mercury suits. Notably, Alan Shepard wore one during his pioneering mission aboard Freedom 7 on May 5, 1961, becoming the first American in space. John Glenn also made history wearing a Mercury suit on February 20, 1962, when he became the first American to orbit the Earth aboard Friendship 7. The Mercury suit, though not as advanced as today's models, played a crucial role in shaping NASA's understanding of space exploration. While it wasn't designed for spacewalks, its use provided valuable insights into managing astronauts' needs in confined spaces and extreme temperatures. These lessons were a must in developing more advanced spacesuits for future missions. Those early efforts resulted in the groundwork for more advanced spacesuits, which also played a big part in the success of later programs like Gemini and Apollo. The Mercury missions emphasized a lot about the importance of using pressure suits for space travel to NASA. However, as the explorations to the Moon got more imminent, NASA couldn't agree more that they needed to learn more about how space affects humans. This is where the Gemini program came into effect. The mission lasted for 1 year only, but the program was important for learning how to explore the Moon. It showed NASA what kind of equipment would be necessary for these missions, from rockets to spacesuits. The spacesuits used during Gemini were tweaked based on what was learned from the Mercury missions. The Gemini spacesuits even surpassed the spacesuits used in the Mercury missions in many ways. Those spacesuits seemed much more fittable to the astronauts when worn and allowed them to test spacewalking, which was vital for future Moon missions. Since 1965, astronauts have done hundreds of spacewalks so far. They spend over 1,800 hours in US spacesuits. These suits have allowed them to do important work in space, from short tasks to long missions. The Gemini suit was the first American suit used for spacewalks in low Earth orbit. At first, astronauts did stand-up spacewalks, where they stood in the open hatch to practice simple tasks. Later, these spacewalks became more advanced. One of the major drawbacks of the Gemini suits was they didn't have any built-in life support system. Instead, astronauts got their oxygen through a hose connected to the spacecraft. Even with this limitation, the 10 crewed Gemini flights showed that astronauts could safely go outside their spacecraft and do important work. This success was key in preparing for exploring the Moon. Following the Gemini, NASA launched the Apollo program, which ran from 1967 to 1975. That mission brought major advancements in spacesuit technology to handle the challenges of exploring the Moon. Apollo's suits were designed to protect astronauts from the Moon's fine, sharp dust and extreme temperatures, while still allowing free movement. These suits had 12 layers of fabric to guard against heat and tiny meteoroids. They also had a portable life support system that provided oxygen, cooling water, and battery power. Even though the suit and PLSS system together weighed over 180 pounds on Earth, the Moon's lower gravity made them feel much lighter. This addition helped astronauts to move around more easily. Time went on, and things were getting more advanced day after day. However, the actual improvement of spacesuits began in 1981, when the Space Shuttle program started. For the first Space Shuttle missions, astronauts wore special high-altitude pressure suits designed for emergencies. These suits weren't made for spacewalks, but were important for protection inside the shuttle. To perform regular spacewalks, like those needed to build and maintain the International Space Station, NASA developed the Extravehicular Mobility Unit. The EMU was a significant improvement. It's a suit with 14 layers. It was designed to protect astronauts from the harsh conditions of space. Furthermore, it also provides life support for over 8 hours. The suit had a helmet with a gold-coated visor to protect against UV rays. Additionally, The EMU included a device called the Manned Maneuvering Unit. The device allows astronauts to move freely in space without being attached to the shuttle or station. Although the MMU was used only a few times, it demonstrated that astronauts could operate independently in space. Private companies like SpaceX have brought fresh ideas to spacesuit design. Notably, SpaceX's Crew Dragon suits were created by Hollywood costume designer Jose Fernandez. These suits were sleek, white, and intended for use inside the spacecraft. These suits feature 3D printed helmets and touchscreen compatible gloves. They are used for missions to and from the International Space Station, but are not designed for spacewalks. Similarly, the giant aircraft company, Boeing, has also developed new suits for its CST-100 Starliner capsules. They unveiled them in 2022. These bright blue suits have a built-in helmet with an airtight zipper, so there's no need for bulky neck rings, and they are meant to be comfortable and safe for transport missions. Coming to the present day, spacesuits have come a long way. NASA's Artemis program, that targets to dispatch the astronauts to the moon by 2025, has led to the creation of advanced spacesuits. The new suits are named as the Axiom Extravehicular Mobility Units. These suits are intentionally made white to keep the astronauts put up with the extreme temperature of the moon, because this white suit will reflect heat. No doubt, they will also be more flexible and durable. In the race of making the most advanced spacesuits, Russia isn't lagging behind. However, they have also made significant advances in spacesuit technology, just like the Sokol suits, which were used during launch and landing on Soyuz spacecraft. Those spacesuits were designed for easy use with a front entry style and provide essential protection for astronauts. Then the Orlan suits, which were used for spacewalks since 1971. They have an all-in-one design with higher internal pressure, which means astronauts can get ready faster and put on the suit by themselves. After taking a short tour through the story of spacesuits, we can see massive progress in space exploration technology. From the early Mercury program suits to the latest designs for future moon missions, the spacesuits have continually met the needs of space travel. Each new design builds on the lessons learned from previous missions, which ensures that astronauts remain safe while exploring space. Spacesuits' vital role. Space is such a place where humans have to face challenges every moment. Whoever goes on a space mission, does some spacewalks, faces the dilemma between life and death. The first challenge for humans is to acclimatize with the environment of space, especially beyond the Kármán line. The Kármán line means the boundary between Earth's atmosphere and outer space. It is situated about 100 kilometers above sea level. Once you're out there, one of the biggest problems you'll face is the lack of oxygen. Without enough oxygen, human bodies can't function properly. But that's just one of the countless challenges astronauts face. Now, a common question often asked by people is, how hot or cold is the space? Well, space is an extremely harsh environment for humans, primarily because of the extreme temperatures. For instance, an astronaut on a spacewalk without a spacesuit would experience temperatures around 120 degrees Celsius when exposed to direct sunlight due to radiation. Conversely, without the sun, the temperature would plummet to about minus 120 degrees Celsius. These drastic temperature changes happen too quickly because there is no atmosphere in space to moderate them. And the only thing astronauts resort to in these conditions is the spacesuit. The liquid cooling and ventilation garment is a key part of a spacesuit. It has clear plastic tubes filled with chilled water to keep astronauts cool. Plus, it has ventilation tubes to remove waste gases. This setup helps astronauts stay comfortable and work well, even in the tough conditions of space. Then, the air pressure. Although we don't feel it, the air surrounding us is pressing us continuously. It is mostly felt when you're driving up steep hills or getting off an airplane. On Earth, the pressure from the air around us balances with the pressure inside our bodies, which is created by our heartbeat. In space, however, there's no air, which means no air pressure. To address the lack of air pressure in space, spacesuits are inflated with air, much like a balloon. This inflation creates the needed pressure around the astronaut's body, which prevents bodily fluids from boiling away and allows astronauts to breathe normally while exploring the cosmos. But spacesuits do much more than just manage temperature and pressure. They also shield astronauts from other threats like radiation, fast-moving space debris. On our planet, there's a layer of the atmosphere that always shields us from the sun's harmful rays. We call it radiation. This protection is why we can be outside during the day without severe effects, as long as we don't stay exposed for too long. However, space lacks this protective layer. Without it, the sun's radiation can be very dangerous to astronauts. To counter this, spacesuits are equipped with multiple layers designed to block and reflect harmful rays. Additionally, they have a gold-plated visor to shield the astronaut's eyes from intense sunlight. Another issue is space debris, also known as meteor dust. These are tiny particles orbiting the Earth, and they're becoming a bigger problem over time. How could a tiny dust particle hurt an astronaut? Well, these particles move at incredible speeds, around 24,000 kilometers per hour. At such high speeds, even a small particle can cause significant damage. To protect astronauts from this, spacesuits have a special shield in the upper part called the hard upper torso. This shield is similar to a bulletproof vest and safeguards astronauts from the potentially deadly impact of meteor dust. Well, spacesuits are not worn for a fashion purpose in space, nor is it a uniform mandated for nothing. They are far more than just clothing for astronauts. This vital equipment is made to protect astronauts from the harsh conditions of space. During space missions, astronauts need to wear different types of spacesuits for specific purposes. One type is worn inside the spacecraft during launch, ascent, re-entry, and landing. Another type is designed for spacewalks or extravehicular activities. These suits are known as the EVA suit. This specialized suit is essential for protecting astronauts from radiation, dust, debris, and extreme temperatures that can range from -250 degrees Fahrenheit in the shade to 250 degrees in direct sunlight. The EVA suit is also referred to as the extravehicular mobility unit. They, shaped like a human body, and function as a miniature spaceship. NASA is developing a new version called the Exploration Extravehicular Mobility Unit for the Artemis missions, which includes several advanced features. In short, they named it XEMU. Despite all these innovations, the core elements of both suits remain consistent to ensure the safety and functionality required for astronauts working outside their spacecraft. A spacewalk spacesuit consists of two main components: the pressure garment and the life support system. The pressure garment is a human-shaped suit. It is designed to protect the body and allow for mobility in space. It consists of various key parts: the cooling garment, the hard upper torso, the gloves, the lower torso, and the helmet. The first layer astronauts put on is the cooling garment. This snug-fitting layer is made of spandex and has around 300 feet of water tubes woven into it. It covers the body except for the head, hands, and feet. Chilled water flows through these tubes to keep the astronaut cool and remove extra heat during long spacewalks. The garment also has vents to help evaporate sweat and improve air circulation inside the suit. The hard upper torso is a robust yet lightweight component shaped like a sleeveless shirt. It connects the suit's interior systems with those in the portable life support system. It attaches to the arm assembly, which covers the arms and joins the gloves. Notably, the new exploration suits feature a rear entry hatch for easier access. Gloves are crucial for astronauts to handle objects and perform tasks while in space. These gloves allow for finger movement too. Since fingers are particularly vulnerable to cold, the gloves are equipped with heaters to maintain warmth and dexterity from smiting the fingers at the time of hand movement. The lower torso of the spacesuit includes pants, boots, and the lower half of the waist closure. These parts are connected to the hard upper torso by a metal body seal closure. The new lunar suits use advanced materials and joint interfaces, which provides greater flexibility at the hips and knees. The new design helped astronauts to walk normally on the lunar surface. instead of having to use the bunny hop movement seen during the Apollo missions. Basically, spacesuits are made of up to 16 layers of different materials, and each layer has a specific purpose. The first 3 layers are part of the cooling garment. Next is the bladder layer, which is filled with gas to maintain body pressure and provide breathing oxygen. Another layer keeps the bladder in place around the body. Plus, there is also a tear-resistant ripstop liner, multiple insulation layers, and a white outer layer that completes the suit. The white outer layer reflects heat and is made of water-resistant, bulletproof, and fire-resistant threads. It may also have stripes to help identify different astronauts during spacewalks. A spacesuit also has a backpack named as the life support system. This system supplies oxygen, removes carbon dioxide, regulates suit pressure, and circulates air. It also provides electricity, cooling water, and a two-way radio for communication. There's a fan that circulates the oxygen, and a pump that moves chilled water through the cooling garment so that the astronaut remains comfortable. The most important thing a spacesuit contains is the communication system. This system is managed through a cap worn under the helmet. Historically, it is known as the Snoopy cap, for its resemblance to a cartoon character's aviator cap. This cap includes earphones and microphones connected to the suit's radio system. In the new XEMU suits, there will be an integrated audio system within the helmet, which eliminates the need for a separate cap. These helmets will feature voice-activated microphones and speakers for improved communication. The helmet itself acts as a pressure bubble, made from strong plastic to maintain suit pressure, and equipped with a ventilation system. Inside the helmet, a foam block allows astronauts to scratch their noses comfortably. The outer protective visor shields the pressure bubble from damage, while a gold-coated sun visor and shades protect astronauts from the sun's rays, ensuring clear visibility. The XEMU helmet also includes a quick-swap protective visor designed to shield against abrasive planetary dirt. Its elliptical shape enhances ground visibility for astronauts. Now let's talk about some numbers. Obviously, some big ones. However, spacesuits are not any fancy wearable or just an ordinary exclusive cloth. They consist of numerous advanced technology and complex engineering, which makes them exceptionally pricey. In 1974, NASA disclosed that a spacesuit cost between 15 and 22 million, which is equivalent to about 83 to 122 million today. This was more than a decade after the first spacesuit, the Mercury suit, was designed for Alan B. Shepard. Since then, NASA has developed various types of spacesuits, and each of them came up with noticeable improvements and latest technology. Currently, NASA is working on a new spacesuit called the Exploration Extravehicular Mobility Unit, which is estimated to cost around $1 billion per suit. This high cost can lead to mission delays due to funding limitations. The XEMU is designed for the Artemis missions and includes the latest safety and functionality features to help astronauts perform essential tasks in space. Spacesuits have always been costly. Since 2009, NASA has invested over $200 million in developing new spacesuits, which led to the manufacturing of the new XEMU prototype. However, creating new suits has been a lengthy and expensive process. The complexity of spacesuits drives their high cost. Dr. Kathleen Lewis, the curator of international space programs and spacesuits, said that the spacesuits should be considered as human-shaped spacecraft rather than just work clothes. They must protect astronauts from the vacuum of space, radiation, and fast-moving particles, while providing oxygen, communication systems, telemetry, and other life support functions. This makes them intricate and technologically dense. The current spacesuits are over 40 years old. Originally, NASA developed 18 suits for the Space Shuttle program in 1974. They have been designed to last 15 years. Over time, some suits were lost or destroyed. Now, they have only 11 of them, and 7 suits are under maintenance. This limited number of suits has caused operational challenges. such as delaying NASA's first all-female spacewalk due to a lack of appropriately sized suits. NASA has heavily invested in the XEMU suit for the Artemis program, which aims to return humans to the Moon by 2024 and eventually reach Mars. With the current suits aging and their components becoming obsolete, NASA faces a new kind of space race. For example, the CO2 sensors in the current suits are no longer produced. They need new designs that work with both old and new suits. Despite the advanced engineering of spacesuits, they encounter issues. For instance, in 2013, European Space Agency astronaut Luca Parmitano experienced a helmet water leak during a spacewalk. Since the Apollo era, spacesuits have been used in over 200 spacewalks. Now, it's essential to invest in new suits. Future missions to the diverse environment like Moon and Mars need suits that allow enhanced mobility and offer more protection. These improvements are crucial to keep astronauts safe and ensure future missions are successful. Well, NASA believes the investment in new spacesuits is justified. Developing suits that align with modern values and expectations ensures better fit and functionality for a diverse crew. Moreover, this development process stimulates the economy by supporting competition and innovation. For instance, initiatives like the 2009 Astronaut Glove Challenge led to the establishment of companies like Final Frontier Design. They focused on producing EVA suits more affordably than traditional NASA models. NASA has not officially released the unit cost of the new XEMU suits, but estimates suggest they will be expensive. However, competition and innovation may drive down costs. Compared to NASA, Russia's Roscosmos has continuously developed new generations of spacesuits, which also provides a more consistent supply of updated suits. In 2017, Elon Musk revealed the SpaceX IVA spacesuit. It is basically made for use inside spacecraft. This suit features a 3D printed helmet and custom-made clothing, showing what future commercial spaceware might look like. There is a growing need for cheaper spacesuits as humanity looks to expand beyond Earth. As Ted Southern from Final Frontier Design says, developing affordable spacesuits and other space technologies is crucial for the future of space exploration and the sustainability of our planet. Each spacesuit needs high maintenance while not in use. Since there remains a huge gap between one mission and another, spacesuits involves continuous monitoring in a detailed and rigorous process. To ensure they remain safe and functional for astronauts, maintenance personnel conduct thorough visual and functional inspections of each component of the spacesuit. They always check for wear and tear, damage from micrometeoroid impacts, and any other signs of deterioration. Furthermore, spacesuits undergo pressure testing to ensure they can withstand the pressures of extravehicular activities. This involves pressurizing the suit to detect any leaks or weaknesses that could compromise its integrity during missions outside the spacecraft. After each use, spacesuits are carefully cleaned and sanitized to remove any contaminants, sweat, or biological materials. This process is important to prevent mold growth and ensure the health of the astronauts. Certain parts of the spacesuit, such as gloves, seals, and visors, are prone to wear and require regular replacement to ensure the suit remains in top condition. Mechanical components like joints and bearings are lubricated and adjusted to ensure smooth operation and flexibility, which is essential for astronauts' ease of movement during spacewalks. Modern spacesuits often include electronic systems for communication, monitoring, and control, necessitating regular software updates and testing to ensure all systems operate correctly. The thermal control systems, which regulate the temperature inside the suit, are also inspected and tested to provide adequate protection against the extreme temperatures of space. Similarly, the suit's life support system, which supplies oxygen, removes carbon dioxide, and controls humidity, must be meticulously maintained by checking the oxygen tanks, CO2 scrubbers, and other critical components. Every maintenance task is carefully recorded. with authorities keeping thorough documentation of each suit's history, usage, and any problems encountered. Maintenance staff receive regular training and participate in simulations to stay current on the latest techniques and procedures. This preparation ensures they are equipped to address any maintenance issues effectively as they arise. Now, the spacesuits have entered into the modern era. They have changed a lot in recent years as private companies have gotten more involved in space travel. They've improved how they look and how they're made. This upgrade is important as we get ready to send people to the Moon and Mars. The main job of spacesuits is still to protect astronauts, but now, with better technology, they're smarter and work better. New materials and technologies have made spacesuits more efficient and nicer to look at. They used to look bulky, but now they're sleeker and more streamlined. In the near future, spacesuits could introduce some next-level capabilities that include self-repairing small holes, generating electricity, and combating germs. ILC Dover LP, a company that's renowned for crafting NASA's spacesuits since the Apollo era, is currently experimenting with these innovative smart fabrics. These advanced suits feature a unique gel nestled between layers of polyurethane. This gel has demonstrated the ability to automatically mend small holes up to 2 mm wide in vacuum chamber tests. For larger breaches, the suit's embedded circuits are designed to break, and they will trigger the sensors, so astronauts get instant alert to the damage. This breakthrough in spacesuit technology means they'll be tougher and safer. It's a big step towards that will give astronauts more confidence during future space missions. The new spacesuit materials being tested have some impressive features. For instance, they include flexible solar cells that generate power, silver-coated layers that kill bacteria by releasing silver ions, and polyethylene layers that block radiation effectively due to their high hydrogen content. NASA is working closely with companies like Collins Aerospace, ILC Dover, and Oceaneering to develop advanced suits for spacewalks. These next-generation suits are designed to fit astronauts of various sizes better, allow for more movement, and incorporate technologies that improve their durability and ease of maintenance. Under the Artemis program, NASA is creating the XEMU for missions to the Moon. These suits will provide better mobility, protection, and visibility for astronauts during lunar exploration. Lessons learned from past missions such as Apollo, Skylab, and the Space Shuttle are guiding the development of these new suits. However, SpaceX is not lagging behind in the race of spacesuit development. This American aerospace company has introduced innovative suits known as the Starman suits. These suits are made using 3D printing technology in a single piece and are tailored individually for each astronaut. Although they aren't meant for spacewalks, they come with practical features such as gloves that can operate touchscreens. Designed for simplicity, once plugged in, they require minimal attention from the crew. In preparation for their upcoming Polaris Dawn mission this summer, SpaceX has unveiled a new EVA suit. This suit, similar to their IVA suits, has been upgraded for use in the vacuum of space. It includes improvements in materials and joints to enhance mobility and protect astronauts in space's challenging conditions. Chris Trigg, SpaceX's spacesuit team manager, highlighted the addition of a new thermal management layer and integration of thermal materials originally developed for Falcon and Dragon spacecraft into the suit's design. Spacesuits are not just ordinary pieces of cloth. These suits come with a rich history sewn into their every thread. From the first inception to today's high-tech versions, they have played the most important role in space missions by safeguarding astronauts. As the days pass, spacesuits are adopting new technologies to enable astronauts to tackle increasingly complex tasks in harsh environments. Despite these advancements, these suits still lack efficiency, and astronauts encounter challenges in terms of technology, durability, or mobility in every mission. That's why NASA, SpaceX, and other innovators are constantly striving to add exceptional, out-of-the-box features to these spacesuits.